Everyone, welcome back to my channel. So we were discussing about the electromagnetism. So up to now we have discussed about the moving charge in a magnetic field, and then we have discussed about the current carrying wire placed in a magnetic field. And previous what we have discussed is, if a charge is kept in a uniform magnetic field, then the force acquired is F is equals to QVB. And when the length of the wire, when a wire is kept in a uniform magnetic field, it gets deflected due to the magnetic force, and that force will be find out by F equals to BIL. Okay, so this is what we have discussed in our previous, and next we are going to discuss about the uniform and non-uniform. Sorry, we are going to discuss about the weak field and a strong field. So what are weak fields and strong fields? So before going to this, there is an experiment which is just like an Oersted experiment, but it's not an Oersted experiment. So we have taken two V sticks which are insulators, and a iron wire is been passed through it, and which is connected to the battery and to the switch. If you want, you can connect to the ammeter also if you want it, otherwise no need. And now when we switch on the key, the current passes from the positive terminal to the negative terminal. As we know, it produces a magnetic field around it. Now in Oersted experiment, we keep a magnetic compass. So we keep a magnetic compass, and with the help of this deflection we show that there is a magnetic field around the wire. But now here, instead of magnetic compass, we take a horseshoe magnet, and this horseshoe magnet is placed over it. And this horseshoe magnet is placed over the wire, north pole and south pole. Now when a horseshoe magnet, so horseshoe magnet is the only magnet which produces a uniform magnetic field. So in the examination they may ask you which type of magnet will be used to produce a uniform magnetic field. That is only a horseshoe magnetic field. So you cannot take a bar magnet or ring magnet or a disc magnet or any other magnet. Only the horseshoe magnet can produce a uniform magnetic field. Why? Because see, here the north pole and south pole are facing towards each other, and the field lines, the magnetic lines, are passing parallel to each other. So if magnetic lines are parallel, that means the field is a uniform magnetic field. So only a horseshoe can produce a uniform magnetic field. Okay, or otherwise if you want a uniform magnetic field, just we have to take two bar magnets. This is the north pole, south pole, south pole, north pole. As if you see north and south, here also you will get a uniform magnetic field. So same thing also, you have to take a horseshoe magnet which produces a uniform magnetic field, and you have to place over it. That means you have to place over it like this. So this is a horseshoe magnet, and the wire will be placed over it like this. Now as the current carrying wire produces a magnetic field, and the horseshoe also produces a magnetic field, so the combination of these two get clumps together and produces a magnetic force, and that magnetic force is responsible for the bending of the wire. That what we have discussed previous. So why it has been bending, that we will see today. That is due to the produce of weak field and a strong field. So let us see what are the weak fields and strong field. First I am going to draw the magnetic field of the magnetic lines of this horseshoe magnet. So horseshoe magnet, they produces a uniform magnetic field, so they are always parallel to each other. So they are parallel to each other. Next, a current carrying wire, which is you can take it as a dot or an into. We can take anything, a dot or an into you can take. That means with respect to seeing whether it is coming outside or whether it is going inside, that depends upon relatively. So I'm taking here the current which is passing out of the page. So out of the page, in sense, you have to put your thumb up. So you have to put your thumb up. So the magnetic field direction will be in a which direction? Anti-clockwise direction. So this is the magnetic field of the wire which is passing in a anti-clockwise direction. Yes. So this is the magnetic field which is due to the horseshoe magnet, and this is the magnetic field due to the wire which is passing around it. Now what happened when these two come together? Like as they were separate before, now we are combining these two. Now when we combine these two, they produces a weak field and strong fields. How that can be produced? I see. So the resultant of these two magnetic field produces, as if you can see here the magnetic lines, both are in same direction. So here both are in same direction. So with respect to this wire, so the magnetic lines come closer to each other. As they all are combining, they come closer to each other, and as there are many number of lines in this place, so we call this as a strong field. And if you observe here the magnetic lines which are opposite to each other, here the magnetic lines are opposite to each other. So when they're opposite to each other, these lines collide each other and they move far away. So they move far away to each other. Now this field, the upper field, which is called as weak field. The upper one is called as the weak field. Now with respect to this, the wire, this is the wire. So the below one is the strong field, the above one is the weak field. Now can you say in which direction does the wire bends? Either in a strong field or weak field? See, here the strong field means it doesn't allow the wire to bend. Why? Because here the field lines are very strong. So that means it doesn't allow any force over there. So obviously it moves to the weak field. As the field over here is weak, so the wire will bend in towards the weak field. The wire cannot bend towards the strong field. Why? Because as the field is strong, it won't allow the wire to bend downwards. So here the wire should be bent towards the weak field, so that it will be bending in a upward direction. So the wire which is present over here, it moves in a upward direction. Okay, so based upon this, we can say that a strong field and weak field is responsible for the bending of the wire. It is responsible for the bending of the wire. Now, how can we explain this figure? How can we explain this figure in terms of weak field and strong field? Simple. So as we have external magnetic field, so the external magnetic field is into the page. Clear? And we have a wire. And the wire is moving in a upward direction. Now, forgot about the uniform magnetic field. I forgot about the external magnetic field which is present here. Just forget about it, and you have just a single wire over here. Now, as this wire produces a magnetic field around it, so we have to divide the page into two. That is, this is the wire which is passing, and we have to find out the magnetic field around it. That is with the help of a right hand thumb rule. So as the current is moving in a straight line, so your thumb should be represented in a upward direction. And here, if you see this, assume this as a wire. So this is a wire, and here on the left side we have which is coming out of the page, isn't it? On the left side, that is on the left side of the wire, it is coming out of the page, and on the right side it is going into the page. So as it is going into the page, and on the left side it is coming out of the page. As I told you before, anything which is coming out of the page is represented as dot. Clear? Now on the right side, as it is going into the page, downward into the page, so we have to represent it here on the right side as into. Now is it clear? As the current is moving upward, so this side, the right hand thumb rule, it is coming out of the page, and this side is going down of the page, so that is into the page. Now place this same over here. So this side is dots and this side is into. Now can you tell me where is the strong field and where is the weak field over here? Yes, see, as into, so these two are same, right? At this side all the magnetic fields are same, so this side we call it as strong field. And if you observe on this side, see here we have an into and a dot, an into and a dot, like opposite to each other. So here on the left side we get a weak field. And can you tell me, students, on which side does the wire bends? To the strong field or weak field? Yes, so the wire bends towards the weak field. Okay, so it cannot enter into the strong field, it will be enter into the weak field. So the wire bends towards the weak field. So that is what we have discussed previous in this one. On what we have discussed in the previous this, it moves towards the left side. The same thing also happens over here. Another one exercise, for example, if we take and magnetic field which is out of the page. So this is the magnetic field which is out of the page. Now you need to find out the weak field and strong field on both sides. Which side will be the weak field and which side will be the strong field, that you need to find it out. So this is the wire. Shall we move it or up or down? Yeah, here we have taken up, so we'll take it also up on the same side. Let us make it up. Okay, now see, apply the same as it is moving in upward direction. Take and apply over here the same. So on the left side, on observing over here, left side we get dots, and on the right side, on this side we get intos. Now if you observe, all these sides are dots, which are called strong field. On the left side, on the right side, we have an into and a dot, which is weak field. Now can you tell me on which side does the wire bends? Towards the strong field or towards the weak field? Yes, it bent towards the weak field. So this is how it gets bent. Clear? Is it clear with this? That is what we call as a strong field and weak field. And you might have observed an old CRT TVs. Old CRT TVs, like in our home televisions, there are some like big Dappa TVs in olden days. They are having the black and white TVs. So if you bring a bar magnet towards this old CRT TVs, not the new LCD one, the bigger, the heavier one, the CRT TVs, if you bring a bar magnet towards these old CRT TV, what happened? As due to the magnetic field which is present inside the CRT TV, in the CRTs, and the magnetic field due to the bar magnet, the both get clumps together and produces a strong field and a weak field. So due to the producing of this strong field and weak field, so the electrons which are emitting inside the TV will get deflected out. That means it moves towards the any other area where there is a weak field. So due to that, we cannot get a clear picture over here. Again, if you remove the bar magnet, so the electrons will be falling upon the screen which you are seeing, the front side the screen, and you will get the clear image. But when you insert a bar magnet, so the magnetic field of these and the magnetic field of this bar magnet, they both get clumped together and produces a weak field and a strong field, and that results make you not to make the electrons to fall upon the screen, and you will not get a clear image. And also one more thing, what you might have seen some of the robberies doing into the rob. So what they'll do is they'll keep a bar magnet or a small ring magnet near to the CC cameras. So when you keep a bar magnet or any ring magnet or any playing magnets near to the cameras, the CC cameras will not be working out. So that is why, because the CC cameras which are producing a magnetic field around it, when you insert any magnet, attach it to it, so due to this magnetic field, so the CC cameras will not be working. That means it will not be recorded out. So that is why, due to the producing of the weak field and the strong field over here. Clear? Next, if you understand this, will be going on to the new exercise. As I have told you before, that we'll go on to the exercise. So now we are going on to the exercise here. So make sure that you are getting a clear, good answers. So here what you have to do is, you have to use your right hand thumb rule and a right hand rule. Clear? Next, see, in the first case, as a current is moving into the wire, and as it moves, it produces a magnetic field around it. So that magnetic field, that we have to find out that where is the magnetic field produced, whether it is a dot or into a dot, that we have to find out. So as I told you before, by using right hand thumb rule, so the current is moving towards the right side. So place your thumb towards the right, and suppose this is the wire and it is moving. The pencil nib is the direction of the current. So this is the direction of the current. Both are same. Now on the upside, if you see, it is coming, the magnetic field is coming out of the page, and on this side it is going into the page. As it is going into the page, now can you tell me, on upper side what we'll get, either into or dot? Yes, we'll get a dot. Why? Because it is coming out of the page. And on this side it is going inside, so we'll get an into over here. Is it clear? Next, it's quite interesting when you understand this electromagnetism. So everybody thinks it is a tough subject, but it's the easiest subject if you get to understand anything. Next, coming to that second one, now here we have to find out the direction of the current, and they have given you the magnetic field. Here it is into the page, and here it is out of the page. That means the magnetic field are coming from, starting from here and ending to there. That means it is coming from here to here. So 3 seconds time for you to find out on from where to where does it moves. So here the magnetic field is starting from here and going into the page on that side. So find out, we don't know the direction of current, so take a pencil, and as it is starting from here, you should keep your fingers like this. As it is coming up, so keep it on up, and it is going into the page on the other side. So into the page, out of the page, and into the page. So out and into. Open your thumb. Now can you tell me what is the direction of the current? Yes, the thumb represents the direction of the current, which is on the left side. So this is the direction of the current. So as you know, this into the page, which is a right hand thumb rule. So into means it should be downward. So what does direction it shows? Clockwise or anti-clockwise? So it shows a clockwise. So that will be the direction. Now coming for this, out of the page, find out that whether it will be clockwise or anti-clockwise. So it will be anti-clockwise direction. Now in the other case, in examinations they may ask you like this. So they will just draw the magnetic field lines, and you have to find out that whether the current is coming out of the page or into the page. As the current is moving in a anti-clockwise direction. So as it is moving in anti-clockwise direction, your thumb is facing upward, so that is outward. That is we represent as dot. And coming to here, it is moving in a clockwise direction. So it is moving in a clockwise direction. Your thumb faces towards downward direction, that is into the page. So you have to write it as into. Next, coming to the next one is, here we have a dot into, and you have a dot. That is the magnetic field lines are the current is traveling from the dot to the into, that is from here to here. Now what you have to do is you have to find out the direction of the magnetic field. So this we have done before, as we discussed it earlier in a circular loops. In a circular loops we have discussed about this. So we have discussed this in a circular loop. How we have discussed it from starting from dot to into. So the current travels from here to here. The magnetic field direction points towards the up point. The same thing also we will be having over here. So it is coming starting from here, ending to here dot. So coming up and going down. The thumb represents the direction of magnetic field. Clear? Now coming from this to this, it is coming from up on the other side and coming down towards my side. So the thumb represents the direction of magnetic field, which is on the right side. The same as thing here also, you have to find out the current direction, whether it is into a dot, that you have to find out. They have given you the magnetic field direction. So the magnetic field direction which is passing towards right, and here on the upper side, this is the magnetic field direction. Here we get dot and here we get into, as it is moving down. Coming up dot, going down into. So we will get here dot and we get here into. And the same case over here also. Here the magnetic field direction on the left side. So you have to you place your thumb towards the left, and here it is coming up, that is coming up dot, going down, coming up dot, going down into. So dot and into. Clear? Next is coming to the right hand rule. So coming to the right hand rule, here in the right hand rule we have a positive charges, and here what we have to do is we have to find out the magnetic field, whether it is into the page or out of the page. So here the force is moving in downward direction, and this is the positive charge moving towards the right, and we have to find out the direction of the magnetic field. So this can be found out with the help of right hand thumb rule. So with the right hand thumb rule, the middle finger represents the magnetic field, the forefinger represents the current, and the thumb represents the direction of force. So if you place the direction of the positive charge, which is on this side, and the force is moving towards right side. So just what you have to do is, comparing to this, the direction of positive charge is okay, and coming to this, the force which is in downward direction, just flip your thumb towards the right. Now is it clear? This is the direction of positive charge and this is the direction of the force, and the middle finger indicates the direction of magnetic field as it is pointing towards you, that is upward. That means whether it is into a dot, if it is pointing outward, that means it is a out of the page, which is represented as dot. So it is represented as a dot. So it is a fun activity. So a fun activity which makes your brain more thinking. The more you think, the more you get the ideas. And here coming to here we have an electron. It's not a proton, it is an electron, negative charge, and the force is moving in upward direction. Now you have to find out that the magnetic field is in upward or downward. Simple. Use the right hand thumb rule. The right hand thumb rule is only for the positive charges only. So the electron, assume it as a positive charge, move it to your side, and electron, place your finger, both are same, and the force is in moving towards the right side. So flip your finger. Is it clear now? Now the electron direction and your finger direction both are same. The force direction and the thumb both are same. Now the magnetic field direction is pointing upward, right? But actually it should be a upward. That means it should be a dot. But here it is an electron. Electron should be opposite. So if it is outward, that is dot. The opposite of dot is into. Opposite of dot is into. So actually we should get dot here, but as it is electron, we get an into over here. So once you practice, you will get these clearly. It's very easy one. Now coming to here, whether we have to find out whether it is a proton or an electron, that is positive charge or negative charge. So this is, I'm giving you an exercise for you, these two. So these two I'm giving you an exercise. Once you can pause your video and you can do it yourself and find out whether it is a proton or an electron. Here also you can find out whether it is a proton or electron. So just using your right hand thumb rule. So the right hand thumb rule, so it is moving in this direction, and the force is acting F, which is in downward, and the magnetic field is pointing outward. So just find out that simply. This is the charge which is moving in this direction, and the force which is coming in downward direction, the magnetic field is coming upward. If these three are same, then here it is an into means which should be in a downward direction. So as it is in a downward direction, the charge direction is same. Here our force should be upward, but here it is in downward direction. That means opposite. Actually, I have told you the right hand rule is for the positive charge. So as it is in opposite to each other, so here we get a positive charge or negative charge. As it is opposite, so we get a negative charge, that is electron. At the same time also you find out this. So find out and give me your answer in the comments, and if you find out the answer, please answer your answer into the comment box. Clear? So today what we have discussed about the strong field and a weak field. So we have discussed about the strong field and weak field. So where the field is weak, the wire bend towards the weak field, and where the field is strong, the wire bend towards the wire cannot bend towards the strong field. Is it clear? So that what we have discussed about the weak field and strong field, and we have done a small exercise upon this. So this is the exercise upon it. And before going, I have a question about that. If you can find it out, please find it out. At the end of the electromagnetic chapter, I will explain it. So I have two wires. So these are the two wires. Like in our front of our home, we have a line, the wires which are passing out, right? So one is the black wire and another one is the red wire. So this is the black wire and another one is the red wire, and these two are passing the current in the same direction. Now you might have observed during the rainy season, whenever we get a strong wind flow, automatically the power stations will switch off the power supply. So why? Because due to the strong winds, the two wires will come closer to each other. So what happened? Why does the two wires get attached when there is a strong wind over there? That is, one is a live wire and another one is neutral wire. So as if these two come together, why does they get attract to each other? So will they attract or will they repel? That you need to find out. And another case also, this is the another case I am giving you. So this is the another wire, electric wire, which is passing upward, and this is the another electric wire which is passing downward. Now will these two wires attract each other or repel each other? So will these two wires attract each other, repel each other? That means what I am saying is, so there are two wires, so both are passing in the same direction. In one case same direction, in another case different direction. So will they attract to each other like this, or will they repel to each other like this? So will they repel each other or will they attract each other? That you need to find out, and comment your answer in the comment box. So the answer will be revealed at the end of the electromagnetic chapter. So thank you for your time. Any doubts, please subscribe. Thank you for your time.